Hey guys, welcome to my channel. Hope you're well. If you're learning DevOps at the moment or even considering becoming a DevOps engineer in the future, then you should know already that Docker is a required skill. If you have about 5 minutes to spare, in this video you will learn what is Docker, difference between VMs and Dockers or containers, main benefits of Docker. So what is Docker? It is an open source software which is used to create, ship, and run applications within containers. Docker containers are very lightweight, which don't consume much additional resources apart from what's required for your application. Normally, people run multiple containers on the same server. All you need to do is create a Docker image using Dockerfile, which is a blueprint to install and run your application in a container, along with its dependencies like binaries and libraries. You can then push your Docker images into a repository in Docker Hub. From there, you can pull the images into your dev, test, and prod environments to create and run your containers. Let's look at 4 different approaches to deploying applications. A traditional approach is, of course, you always start with a server on which you install operating system, and then you install the required binaries and libraries, and then you deploy your application. An example of such architecture could be a bare metal server on which you install a Linux operating system like CentOS, then you install a web server like Tomcat, and then you deploy a web application. Now let's look at another approach, deployment on VM with type 2 hypervisor. You might ask, what about type 1? We'll get to that in a minute. But here you have some hardware. On that you install an operating system. On that you run a hypervisor, then a guest operating system, then your dependencies. On that you deploy your application. In this type of deployment, you can expect to waste a lot of resources like CPU and memory to run that extra operating system. Now, these are some examples for each layer. 2 things which are different here are hypervisor and host operating system. Now, the best thing about having a VM is you can create images. VM images contain the guest operating system, binaries, libraries, and the application. Once you have the image, you can create more identical environments for other purposes. Let's move on to the next approach. This one is almost the same as the previous architecture, except that you install type 1 hypervisor directly on the hardware. You don't have this host operating system lying around and just eating up your resources. Now, these are some products you can use in each of these layers. Similar to the previous approach, you can still create VM images. The only disadvantage is that since you don't have the host operating system, you do need a separate management server to manage these machines. Finally, the Docker container deployment architecture. Of course, you always start with the hardware and an operating system. But apart from that, you just need to install Docker engine, your application along with its dependencies. In reality, it would look like a CentOS operating system installed on a bare metal hardware with Docker engine, web server, and web application. Similar to VM images, you can create Docker images here which only contain binaries, libraries, and your application package. Docker images are much smaller than VM images. Since they are small, you can pull these images to and from Docker Hub really fast. All containers created from a Docker image will be uniform and behave consistently. The chances of environment issues happening are really low. Finally, in microservice architecture, you have a collection of self-contained application units. Each unit serves one specific business function. Suppose your application is made of dozens of microservices with different tech stacks. Managing these through VMs can get really complex unless you package each microservice in their own set of containers. This is why Dockers are best suitable for microservice architecture.